Hey everybody, and welcome back to Sweatpants BI. It's me, Sean, here again, and this time kicking things off with some exciting news that I have, and that is that a few months ago I started a new position with sort of a subsidiary of Humana, where I've been working now for several years. And I'm now the Director of Business Intelligence for Centerwell Home Health. Still sort of a scary title that I'm getting used to. I have never had director in my title before, and of course, with that, I guess to paraphrase Spider-Man, with great power comes great responsibility, or at the very least, with great title comes great responsibility. And obviously, I have a whole heap of work and learning on my plate that is sort of stealing me away from some of my side hustles, like teaching classes for Udemy and providing great Power BI content here on my Sweatpants BI YouTube channel. So, given that I don't have a whole lot of bandwidth at the moment, I'm actually going to, for this month, present one of the full-length Power BI tutorials from my most recent Udemy course, my Power BI Portfolio in a Day class, this time offering you on my YouTube channel my Austin, Texas Housing Insights walkthrough. This is a really exciting data set to play with if you're someone who enjoys Zillow trolling like my wife and I do, or if you just like working with geolocational data. This data has all of that. You'll get to work with thousands of houses around Austin, Texas of different sizes. You'll get to work with some demographic data in those areas, things like school districts, but also obviously a lot of dimensional data sort of about the different houses that are in that data set. Things like the number of bedrooms, lot size, size of the house, kitchen features, things like that. That made this data set a lot of fun to play with, and in my humble opinion, one of the highlights of my Power BI Portfolio in a Day class on Udemy. Not that I'm asking you to check that out if you haven't already, but you might want to consider it. But let's go ahead and get into this month's full-length Power BI walkthrough, going into that housing data. And of course, we're going to start things off the way that we always do with full-length Power BI report builds on this channel. Instead of getting right into the data viz or into some of the design elements, we're going to start with the data set itself. That data set, of course, is available in the description for this video, where I will be providing just a Google Drive link for you to go to and download that data set, and probably several others that are used in some of my Udemy classes that might be helpful for you. But let's go ahead and head back over to our computer and open up Power BI Desktop, bring in that housing data, and start to model it so that we're going to set ourselves up for success when we get to actually building a really cool and fun Power BI report that our users are going to be very excited to use to explore a bunch of housing data. So I'll see you over there. So as always, we're just going to start here in a blank Power BI report. You can see over here on the right, I haven't connected to any data yet. So the first thing that we're going to do is just connect to our data. And of course, you can always just go up here to your home in your ribbon and select Get Data. And there are all kinds of different sources that you can use. However, I prefer to do this exercise directly through the Power Query Editor, which if you go up to your ribbon, your home ribbon, that's just this little table icon with a pencil indicating that you can sort of edit your data sets and go ahead and add new data as needed. I also like to connect my data sources in the Power Query Editor for the primary reason of just you're already in a location where you can take those data sets and transform them and clean them and do a whole bunch of the pre-work that I recommend you do before you start actually visualizing or building your Power BI report. So let's go ahead and start here in our Power Query Editor. I'm going to be adding a new data source, and I'm going to be connecting to a CSV file. So let's go ahead and select that. Let's wait for my little, there we go, housing data. I was waiting for my window to pop up. I'm going to go over here to Data, and here is our Austin housing data. So let's go ahead and open that. It's going to bring up my data set here. Looks like I've got a little bit of a glitch happening with some overlap, but nothing to really get in our way too much. Let's go ahead and hit OK. And the first thing that I want to do before we start modeling this data is let's just do a quick overview of the kind of data that we're working with. There are all kinds of different data sets that I could have used for this tutorial, but I really liked this Austin housing data set because it's got all kinds of cool different data types that I don't necessarily work with a whole lot in these sorts of tutorials, but they're absolutely things that you could run across as a BI professional or someone who's building a report in Power BI. For example, just off the top of the, right out of the gate, you've got this long description field that has all kinds of free text. It looks like at a glance, most of it's fairly clean free text in the sense that I'm not necessarily seeing a whole bunch of typos or really, really weird stuff. You know, I mean, like I troll websites like Zillow and Realtor.com all the time, especially as someone who just purchased a house in the last couple of months. So, I mean, all of this stuff looks pretty standard. You know, all of these are just sort of text blurbs like you might see on something like Zillow, kind of describing the house, you know, with all kinds of like adjectives and sort of like marketing or sales stuff that's, you know, intended to attract buyers. But, you know, there's all kinds of this cool, free text that might be potentially cool to visualize down the road. We also have a latitude and longitude field, which are always super, super interesting for me. I'm kind of a geo nerd. I love maps and stuff in my reports. And most of the time, the best that I get when I'm visualizing stuff is I might get an address, or I might have like a state field, maybe zip codes. It doesn't get much more precise in Power BI than actually having lat and long data points. So we should be able hypothetically to take all of these unique IDs that represent properties in the Austin housing market and map those more or less exactly where they go on a map around Austin, Texas. So having that latitude and longitude information is going to be really, really cool for us to visualize. Kind of scrolling through the next few fields, you know, we have things that you would expect to see on something, on a website that's advertising different properties. We have like property tax rates for the different areas around Austin, Texas, the number of garage spaces that these houses have. We have some additional features like presumably whether or not it has a homeowners association. If you're someone who lives overseas, or if you're watching this video from another country, and maybe you're, the concept of a homeowners association is foreign to you, or maybe you know where you live, this is called something different. A homeowners association in this country is really just an association oftentimes managed by a private company in sort of collaboration with residents that live in a neighborhood or in a community where all of the residents, you know, pay, you know, maybe a few $100 a year, maybe a few $100 a month, sometimes ridiculous amounts of money in really, really nice neighborhoods, sometimes like, you know, a few grand a month, just for the overall upkeep of the neighborhood. You know, things like landscaping and, you know, maybe these prices can be even higher in neighborhoods that have like private golf courses or gyms or community centers, things like that. So by homeowners association, it's basically just indicating whether or not there's an additional fee that residents have to pay just for the privilege of living in a certain community or neighborhood. And as you can see here, it's true, 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 true. You know, you can see there's a lot of trues here. So it looks like in Austin, Texas, a lot of these houses have homeowners associations, which I think is pretty typical of a lot of urban areas. My last 3 houses and my current one have all had homeowners associations. It's a pretty common thing here in the United States. But I digress. There are other fields here that just indicate, you know, whether or not the house has cooling, heating, whether or not it has a garage, whether or not it has a spa. I'm seeing a whole lot of falses here. There's a true. I'm not even personally sure what is meant by spa. I just know that a lot of the houses here probably don't have one, and to my knowledge, none of my houses have had one. Sounds like a pretty exclusive perk. Something tells me that whether or not a house has a spa is probably going to be associated pretty strongly with pretty high-priced properties in this data set. Whether or not it has a view, I'm not exactly sure what they mean exactly by having a view, but it must have a view of something desirable, you know, something that a homeowner would justifiably want to pay more money for as opposed to other properties that don't have a view. Next, we have probably what is going to be a very important slicer in our report, if I had to guess, just describing the type of homes in our data sets. And you can see we have apartments, condos, multifamily residences, which tend to be buildings where you have multiple families sort of living in apartments that border each other within or neighbor each other within a building. Residential, single family, townhouses, vacant land, or in other words, undeveloped properties. So, there's about 10 values here. Those could be pretty important for sort of dissecting our data. We also have some fields here indicating the number of parking spaces, the year that the house was built, the asking price or most recent price for these houses in US dollars. So you can see we've got properties here at around $305,000, $309,000, $315,000. I see a lot of ones and twos and threes. There's a property that it looks like $4.3 million. So definitely out of this BI developer's price range. But good on you if you're looking at this and you're thinking I could afford that. In which case, I'm wondering, why are you bothering with building BI reports? But hey, good for you. We have the number of price changes. We have the latest sales date. In other words, when was the last time that this given property was sold? And you can see this is a pretty recent data set. I'm seeing 2019, 2020, 2018. We have the most recent sales month, which it looks like is just extracting the month from latest sales date, latest sales year, same thing. The latest price source is just whether or not it's an agent or a broker or some type of other realty company sort of providing that information. The number of photos that are presumably associated with the Zillow URL or other realty website URL for these houses. So, for example, looks like here's a house that has 29 photos, 39 photos, 37 photos. You all are smart. You all know what this means. I'm just going to go ahead and jump through really quickly. We have accessibility features, presumably for people that might be handicapped or in wheelchairs or have other needs that a house can accommodate. We have the number of appliances, presumably things like refrigerators, microwaves, ovens or ranges. Parking features, honestly, I'm not completely sure what those are. Patio and porch features, security features, maybe like cameras or an alarm system. Waterfront features, I'm not seeing a whole lot, but I don't know. Maybe there are like large lakes or other water features in Austin, Texas that some of these properties border. Maybe they have like docks or something to allow for boats. We have window features, which I'm not exactly sure what they are. Community features is also pretty vague. And as we get towards the end of the data set, we have things like the size of the lot, or in other words, the size of the property that the house sits on. And then we also have the area, the amount of living area in square footage. And we also have some additional fields that just kind of talk a little bit about the neighborhood that the house is in, primarily through the lens of education. If you're a family looking to buy a new house and you have children, things like the number of primary schools, elementary schools, middle schools, high schools, and the average distance to those schools and the average rating of those schools and the number of teachers per student, things like that are probably going to be pretty important in your long-term designs and living in one of these houses. Even though my wife and I not having children, not a huge deal breaker for us where the schools are located. And finally, as we wrap up, just because we're at the end of the data set doesn't mean that these columns aren't important. You've got some pretty good things here, like the number of bathrooms, the number of bedrooms, the number of stories. That means the number of levels in the house. I'm not sure whether or not story is a word or concept that transcends the many languages that someone watching this may speak. But the number of stories is just the number of levels in the house, and I would expect to see 1 and 2 primarily across the board, but I definitely wouldn't rule out seeing a 3 or maybe even a 4, but probably not much higher than that based on my own experience. And then, of course, we've got some home images, which unfortunately I'm not going to be able to do too much with. These are just JPEGs, almost to like a local storage. I don't know if I really have a means to be able to decode these images and actually incorporate those into my report. So we probably won't be able to use this home image data set. If this is something that you want to pursue and try to get those images working, by all means, just letting you know that I'm probably not going to focus on getting these images turned on within the context of this data set, because I don't think that I have the underlying image data anywhere connected to this data set. But as you can see, a very interesting data set, full of all kinds of unique data types, plenty of room for us to build a really cool report, which is why I chose it. So let's go ahead and get cracking with this data set. The first thing that I'm going to do is I'm just going to close and apply real quickly. And I'm just going to save a copy of this data set or of this Power BI report with the source data set loaded. I'm going to go ahead and save as. Let's go ahead and browse the device. I'm going to save this in housing data and in my tutorial folder. And I'm just going to call this first version test. And that is because I really want you to see the payoff of some of the transformations that we're going to be making in the Power Query editor in the next video. Next, let's go ahead and head back to the Power Query editor. And here, I'm just going to take my source data set and I'm going to right click on it and I'm going to disable the load by clicking this enable load and just unchecking the check mark next to enable load. And you're going to get this pop-up that says possible data loss warning, and disabling load will remove the table from the report and any visuals that use its columns will be broken. This is just a warning telling you that if we were in the middle or at the end of developing our Power BI report, removing this data set could screw up a lot of things. But because we haven't even started visualizing anything yet, this is irrelevant. All it's going to do is just remove our data set from the front end. I'm going to go ahead and hit continue. And let's go ahead and hit close and apply just so I can show you what's going to happen. And over here, you should have noticed that my data set that I had for my Austin housing insights is now disappeared. I'm back to not having any data loaded to the front end. Even though if I go back to the Power Query editor, you can see my data is still here. It's just locked in the back end or kind of hidden from the visual part of the report. So now I'm going to double click on Austin housing data and I'm going to change the name of this to Austin housing data underscore source. And the whole point of this table is that I'm not going to make any transformations in this part of my data set. What I'm going to do is I'm going to right click again on my source data and I'm going to reference it and I'm going to disable this table and I'm going to call this Austin housing data clean. The reason that I like to work with this structure is it allows me to sort of reference my original data set and then my cleaned data set and then my cleaned data set, or in other words, the data set that I've transformed and sort of polished up, which we're going to do here in just a minute. I can use this to build out my schema of data tables. But I like to always have an unchanged, completely untinkered with version of my data here at an easy reference, especially when I'm working with relatively small data sets like this one that only have about 15,000 rows of data. Nothing too concerning, even though there are, you can see about 47 columns here. But this just gives me a quick place where I can go and reference how my data looked before I did anything to it. Now I'm going to use my cleaned data set, and this is where I'm going to make all of my changes prior to, sort of breaking all of this up and creating a schema of multiple tables, like a fact and dimension tables. So I'm just going to kind of scroll from left to right and sort of make changes on the fly. The beautiful thing about the Power Query editor is that if you think of more changes later that you want to make, no problem. You can always just pop into the Power Query editor and make more changes as you go. I do that all the time. I can't think of almost a single Power BI project where I've knocked out all of my transformations right out of the gate. I'm constantly coming back to the Power Query editor, even though it may seem like because of the nature of these tutorials that I do everything up front. That's absolutely not true. So the first thing that we're going to do here is I'm noticing that I have cities like Austin and Pflugerville. I'm assuming I'm pronouncing that right. Those seem to be the two big ones. Let's go ahead and open up our city. We've got Del Valle and Driftwood Manor. I guarantee that I'm butchering the names of a lot of these pronunciations for anybody who lives in this area. But I'm doing the best I can. I've actually never been to Austin. Let's go ahead and go up here to city and let's click on our little down arrow. Again, you can kind of see There are maybe 10 to a dozen values here. Let's go ahead and right click on city. And one thing that I want to do that's just going to make this look a little bit more professional is let's go ahead and capitalize each word in this column so that now all of my values here look like this instead of being all lowercase. Street address looks pretty good to me. You can see it's already got the sort of camel case going where every unique word is capitalized. Next, zip code looks fine to me. I'm seeing a bunch of 5-digit numbers. That's the way it should be. Even my descriptions look pretty good. I am going to perform a whole bunch of transformations on this description when we get to the modeling component of the lesson, but for now, this looks pretty decent. I'm just going to leave it as it is. My latitude and my longitude numbers look fine. My property tax rate looks okay. My garage spaces are whole numbers, which, is what they should be. If you want to open this up and just check, first of all, notice there is a house that has 22 garage spaces. My God, either that is a mansion or it's like an apartment building or something. I don't know, but I like to think that it's a mansion. So this could be my future house that has 22 garage spaces, but I digress. Mostly I'm seeing a lot of 0s and 2s, which is pretty common of American houses. Next, we have our next bit of cleaning that is going to be required. And you can see that I've got a bunch of X and check mark columns. These are binary true and false columns for just indicating whether or not these houses have associations, if they have cooling units, garages, heating units, spas, or views. So let's go ahead and hold down Shift. And I'm just going to select all 6 of these columns because I don't want to have to perform this transformation one at a time on these columns. I want to perform this next transformation on all of these columns at once. So I have all 6 selected here. Let's go ahead and go to transform. And you can see here where my data type is true or false. That is what is indicated by these X and check mark symbols here. Instead of having these be true or false, I just want these to be text. So I'm going to change this to text. Now that X and check mark symbol is replaced by an ABC symbol indicating that these are now strings. The strings still say true or false, but these are now text instead of binary indicators. Now what I want to do is I want to replace these. You could use true or false in your report. Personally, I see that all the time, but I wouldn't necessarily recommend it. You want to try to make your reports when you get to the front end as foolproof and easy to read as possible. And I think personally, it's a little bit, it's a better user experience for your users to see yes and no instead of true or false. You don't want them to have to think about what the true and false means. I know none of this is complicated, but you'd be amazed at how intimidated people get when you put a data or BI report in front of them. We want to keep them happy. We want to make things easy as possible. So let's just quickly go through here and replace the true values with yes. And you can see that those are immediately replaced. We still have our falses to take care of. Over here is our replaced value transformation where we replace the trues with yeses. Let's go ahead and add another replace value transformation that replaces our falses with nos. There's our second transformation. And next, let's just go ahead and scroll through and look for anything else that we might want to make for our initial cleaning of the data set. Overall, this is a fairly clean data set. I'm not too worried, but I'm just kind of clicking through, making sure that everything else here makes decent sense. Average school size. We're good. Okay. And again, at the end, we have this home image, these JPEG files that I'm probably not going to be able to do with. But by and large, a lot of our columns are sort of text and numeric values. So it looks like we're in pretty good shape. For this initial cleaning data set, I'm really not trying to do much else other than to pick the proper capitalization and the proper data types for all of my columns. And most of them are in pretty good shape. So we're done with our initial cleaning. Now it's time to start breaking up this 47 column table into a fact table that contains most of our super granular or transaction level fields for our data, or in other words, things like street address or list price or other things that tend to be more unique than repetitive for each of these properties, and then separate out other things like maybe geographic level information, or zip codes, or some of their amenities that tend to repeat quite a bit, and those are going to be some of our dimensions. So let's go ahead and wrap up our cleaning of the data and start modeling this data so that we can see how much more efficient and smaller this report is going to become after we've properly modeled it. Now it's time to start taking our clean data set and modeling it for our front end, or for the actual part of Power BI where we start building cool visuals and designing a really cool report. So the first thing that we're going to do, and I want to make sure that I'm clear on this right out of the gate, we're always going to be referencing this clean version of our data set as we create our fact table and our dimensions. So the first reference table that I create is going to be a copy of our clean data set, and I'm going to call this housing fact. As I start creating my dimension tables, it's important that you never reference this fact table, because as we get deeper into our modeling and as we start connecting our dimension tables back to our fact table, that's going to be impossible if our dimension tables are created from the fact table, because we're going to create a circular dependency. So it's important that everything references this clean version of our data set, because then we can start connecting all of the other tables, because while they have a common source, they don't actually reference each other directly. That might be a little bit, Sean, I don't really understand what you're talking about. Maybe you're not quite grasping this. If you want to see what I mean, try a version of this, or try following along where you ignore that advice and where you start creating dim tables that reference this. You should, as soon as you start creating merges or joins between these tables, you should start running into the error that I'm talking about. But if you're not concerned with it and you're just like, Sean, I'll do whatever you tell me to do, I don't want to have to worry about it too much, just telling you that as we create our model, always make sure that you're referencing this load disabled clean version of our data set. That way you should avoid running into any kind of problems. So we have our fact table. For now, we're just going to kind of leave this fact table as is. We're not going to do anything with it right now, but our goal at the end of our modeling is to have this fact table cut down from 47 columns to maybe about a dozen to 20. Hopefully a little bit fewer than half of these columns will be remaining in our fact table, and the information that we're removing from the fact table will now reside in the dimension tables that we're going to be creating based off of the clean version of our data set. And doing that should also cut the size of this file down quite a bit, which I'll demonstrate for you when we're done modeling. In case you're wondering, Sean, why can't we just, create a cool report based off this data set? Why are we doing all of this initial work? I want to be completely clear. This is not a big data set. If you wanted to just start playing with this and just start throwing visuals together, you absolutely could. This is not a big data set. But if you had a 1,000,000 row data set, a 10 million row data set, a 100 million row data set, the things that I'm going to show you are just best practice for making sure that you're conserving the performance and the efficiency of your data model. This is small potatoes that we're working with here, so you don't want to go through the modeling exercise. I kind of understand, but I also want you to be familiar with, why we do these things, even if this is on a very small scale. I promise that we're going to see a difference by the time I'm done modeling this. So we have our housing fact table. We're going to be continuing to revisit this every time we create a new dimension table. The first dimension table that I'm going to create is going to be a table that consolidates all of our features, our feature columns, which if you'll recall are things like has association, has cooling, has garage, has heating, has spa, has view. We're going to put all of those values into a smaller dimension table. So the first thing that I'm going to do is I'm going to scroll over here to the right, and I'm going to grab has association, and then I'm going to hold down my shift button on my keyboard and select has view. And that's just going to select everything between has association and has view. Once I have all 6 of those columns selected, let's go ahead and remove other columns. And the next thing that I'm going to do is I'm going to click on my table icon up here. And let's go ahead and remove all duplicates from this new features table that we created. And as I scroll down, you can see there are now only 39 rows in this table. So I've already taken 6 fields from my data set, and I've reduced their size from 15,000 records and change to only 39 rows. Not a whole lot of data at all. I have cut 99% of the records that were in these 6 fields. And if I need to reference these values from my fact table, all I'm going to need is some kind of key to connect this feature dimension to my housing fact table. So let's go ahead and create that key. And the fastest way that I find to create that key is just to add an index column to this field. I usually start at 1, but that's just a personal preference. And let's go ahead and call this feature key. And now we're going to go back to our housing fact table, and our goal is to get this feature key transferred over to our fact table. And once we have that key, we don't need to keep this redundant information in our fact table. We'll be able to remove it entirely once we have a key here that we can use to join. So we're going to go ahead and go home first, and we're going to merge. And we're going to merge our housing fact table and our features table. And it looks like I did exactly what I told you not to do, and I used the housing fact table. So let me go ahead and just show you how to fix that real quickly. We're going to use Austin Housing Data Clean. There we go. There's our 39 records. Let's go ahead and head back to our housing fact table. Let's go ahead and merge these queries. There's my features table. You might have noticed that my features table didn't even show up when I was originally referencing my housing fact table. And that was because the features table was created from my housing fact table, and Power BI automatically realized that would have been a circular dependency. I can't reference a table that was created from the original table. So my features table wasn't even showing up here. That's how I immediately knew, Sean, you goofed it. You messed up. So I went ahead and just changed this back to pointing at the Austin Housing Data Clean data set, and we're good to go now. So let's go ahead and use features. And now I'm going to scroll over in my housing fact table to the same columns that I see down here. And I want to make sure that I join these 2 tables on all 6 of the common fields that they share. So we're creating a multi-dimensional join, just like you might have created in SQL if you've ever joined 2 tables on multiple columns. This is exactly the same thing, or the same idea. It's just we're doing it in the Power Query Editor, which has its own kind of unique nuance here. So we're going to join association and association. And you'll notice if I click on cooling, association is no longer highlighted. So in order to specify these multi-dimensional joins, just hold down Control. Now you'll notice when I select cooling and cooling, numbers start appearing next to these columns. So this is indicating that my first join criteria is being created on has association. My second join criteria is being created on has cooling. If I keep holding down Control, has garage becomes my third join criteria, has heating my fourth, has spa my fifth, has view my sixth, and now our join criteria is complete. So let's just go ahead and hit OK. I now have a link here to my features table. I'm going to click on these branching arrows. I'm going to unselect everything except for feature key. Now I'm bringing in my feature key, and you can see it's 1, 2, other numbers start appearing. There shouldn't be any numbers higher than 39 in this field. And you can see there aren't. That's good. Now that we have our feature key, I can scroll back over here. And let's go ahead and grab these 6 columns, and we're just going to remove them from our fact table, because now if we ever need to reference the information in has association through has view, we're going to reference that information using our feature key and use the values in our feature table to decode those values. So instead of storing all of these values for has association, has cooling, has garage, etc., instead of storing those 15,000 times, we only have to store them 39 times in our dimension table, which is much more efficient and is going to reduce the size of our data model. The next dimension table that we're going to create, I'm going to reference my clean data set again, and I'm going to call this schools. And for this table, what I'm actually going to do is I'm going to go back up here to my clean version of my data set, and I'm going to make some additional transformations. And the reason that I want to make them here is so that they flow organically into my tables. Otherwise, I run the risk of having my joins not work correctly or sort of screwing up my fact and dimension tables. So I'm going to make these changes to my clean data set directly. And what I'm trying to do is I'm going to try to reduce the size of some of the attributes in my in my school fields. Because you'll notice I have these average school distances, which run several decimal places. My average school ratings kind of do the same thing here. And my average school size, you can see, gets pretty granular here. 1,063 students, 1,108 students. I don't necessarily think that I need that level of specificity in my average school size. Maybe I'm thinking, it would be totally fine if I just knew there were about 1,100 students or 1,200 students or 1,300 students. So let's go ahead and perform a couple of additional transformations here. The first thing that I'm going to do is for my average school distance, let's go ahead and transform this column. I'm going to round this to just one decimal place. There we go, 1.3, 1.4, 1.1. And I'm going to do the same thing for my average school rating. Let's go ahead and round this to a single decimal place. And finally, for average school size, I want to round this to the nearest hundred. So I'm actually going to round this not in the direction of my decimals, but in the opposite direction. So let's round this -2 decimal places. So now I've got 1,100, 1,200, 1,600. Let's make sure that this is working more or less the way that I wanted it to. Okay, yep. Okay, yep, that all looks good to me. Now that we have these cleaned up a little bit, let's go ahead and reference our housing fact table just so that we can, or let's go ahead and just look at our housing fact table so that we notice that the transformations that I just made to the clean data set, they're flowing through all of my other tables because all of these tables reference my clean data. So I've got, my rounded average school size, my rounded average school rating, my average school distance, all of that's looking good to me. Now, let's go ahead and head back down here to our schools data set. And let's go ahead and grab anything in our data set that has anything to do with schools. So I'm going to start with my number of primary schools, and I'm going to scroll all the way to my median students per teacher. I'm going to hold down Shift so that I select all of those fields in between. Let's go ahead and remove other columns. Let's go ahead next and remove duplicates. And last but not least, let's go ahead and add a new index column starting from 1, and I'm going to call this school key. Now let's go ahead and head back to our housing fact table, and we're going to create a new merge here. And I'm going to scroll all the way to the end where my school information is, and down here I'm going to grab my schools table. And just like we did before, I'm just going to hold down Control, and I'm going to select all of my columns that are shared between these two tables. Average school rating, average school size, average students per teacher, and that should be everything, 8 columns. There's our schools connection. Let's go ahead and deselect everything except for school key. There are my school keys. Now that I have those keys over here in my fact table, we no longer need to have the redundant information about our schools in our fact table. Let's go ahead and remove those columns. We have now reduced our fact table down to 35 columns. So everything's working the way that it should be. And if we ever need to reference the information about school districts for any of these given properties, all we have to do is just follow the school key map from our housing fact table over here to our schools table over here so that we can look and see, okay, for let's see, for this row 7 for this given property, the school key is 2, which corresponds to this row, which means the median students per teacher is 14, average school size is 1,100, 2.7 average school rating, yada, yada, yada. You get where I'm going with this. So that's 2 dimension tables already down. The next dimension table that I create is going to be kind of a catch-all for all of the other fields that sort of describe any of these given properties. So I'm probably not going to lose that much data from this. Like, this is probably going to be a pretty big dimension table. I want to emphasize you can play around with creating your own dimension tables. You don't necessarily have to create the same number of dimension tables that I'm creating. You can experiment a little bit if you feel confident with this. I'm going to create one or two more fairly large dimension tables just to sort of expedite and move this part of the lesson along. But I want to emphasize that the way that I'm doing it just kind of makes sense to me. I'm sort of using commonalities between these different fields of data to figure out how to parse them into dimension and fact tables. But this is an art. There are other ways of doing this. You may find an even better way that more I would say further optimizes this data model than what I'm going to show you here. I just want to demonstrate enough for you to kind of show you the benefits of modeling compared to not modeling, which we'll get to here in just a moment. But I don't want you to feel like you have to set your report up exactly the way that I'm setting mine up. Anyway, let's go ahead and create one more reference to our clean data set. And I'm going to call this one just house dim, because this is going to be a collection of fields that really capture some of the summary information about each unique house. So we're going to need things like garage spaces, like the number of garage spaces that each house has, home type, which describes the type of house, the number of parking spaces, that'll be good. I'm actually going to skip over things like year built and latest price. Those are things that I can just leave in my fact table, especially latest price and number of price changes. And things like sales date, sales month, sales year, those are going to be pretty unique to the specific properties. Number of photos, number of accessibility features, number of appliances. These are things that are sort of appropriate for this house descriptor dimension that I'm creating. Most of the fields that I'm grabbing here, I'm looking for numeric data. Things like lot size, actually lot size and area square foot, those are really, really granular. You can see like 6011, 6185, those are probably better fodder for my fact table. So I'm just going to leave those where they are, and let's go ahead and definitely grab number of bathrooms, number of bedrooms, number of stories. And okay, that should be pretty good. Let's go ahead and remove all other columns. Looks like I've got about 14 columns left here. Okay, let's go ahead now and remove all duplicates like we've been doing. Let's go ahead and add an index column, and I'm just going to call this house key, which is kind of funny since we're working with a housing data set. Speaking of which, I need to get copies of my new house keys made. That just reminded me. Okay, now that we've got that, let's go ahead and head back to our housing fact table, and we're going to rinse and repeat again. We're going to create another merge so that we can get our house key field over here into this table. Let's go ahead and merge, and let's reference our house table. Let's go up here. Let's find our first column, garage spaces, home type, parking spaces. Need to scroll over a little bit up here. Number of accessibility features, number of appliances. There's a lot of columns here in different places. So of course, be careful and make sure that you're always holding down the control button on your keyboard as you're flipping through all of these. If you'll remember, we have 14 columns, so that's how many joins we should be making by the time we're done with this. 12, 13, 14, hit OK. And of course, we're going to deselect everything except for house key. Once we have our house key field in our fact table, that opens up a whole bunch of new columns for us to drop from our fact table. So let's go ahead and remove garage spaces, parking spaces, and house type, or whatever it's called, home type. Let's go ahead and scroll over and find number of accessibility features. Almost all of these feature columns are getting dropped. Number of bathrooms, bedrooms, stories, those are all getting dropped. There should be 14 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 columns that I just removed. So we're now left with 22 columns here. Next, I'm going to go through and from my fact table, I'm going to remove a couple of columns that I'm not planning to use in this tutorial. So let's just go ahead and drop our home image column. And let's scroll over. I'm also going to drop the number of photos. And that's all pretty good. I think I'm planning to use everything else. Maybe not property tax rate. I don't think that I have any immediate plans to use that, but I'll leave it in there for now. Okay, and we are left with city, street address, zip code, and longitude and latitude, which are the last 5 columns that I am going to spin out of this data set. So real quickly, let's just go ahead and create one more dimension table, and I'm going to call this one location. And this one's easy. I'm just going to go ahead and grab city, street address, and zip code. I'm going to skip over description and grab latitude and longitude, and let's just remove all other columns. And I want to emphasize here that I'm really not going to gain a whole lot by spinning these location fields off into their own table, because this is some really granular location data. If all I had were states or zip codes or cities, I might further reduce the size of this table by removing duplicates. But the fact that I have unique street addresses and latitude and longitude information means that there really aren't any duplicates to remove from this information. This is about as granular as the property IDs themselves, right? You can't have multiple houses at a single street address, and very rarely, and probably not at all in this data set, would you expect to see the same latitude and longitude exactly for any of these houses. So I want to emphasize here that I'm creating a location dimension not explicitly to reduce the size of my model, but just for convenience sake, really just so I have one table that contains all of my geographic data. That makes it a little bit easier for me to find those elements when I need them. And that's really the only reason that I'm doing it here. So we're not necessarily gaining anything here. And in fact, I'm just going to create the ZP ID column from my data set as the column that I'm going to join back on. And since I have all of this information in one place, though, let's go ahead and jump back over to my housing fact table. Let's go ahead and remove that information from the fact table. We're now left with 15 columns, and this data set is already starting to look so much better. So let's go ahead and close and apply here. I am going to create one more table, but it's going to be a doozy. So let's go ahead and just save what we've got so far. Let's go ahead and we've got our housing fact table and the 4 new dimension tables that we created. Let's head over here and make sure that everything joined correctly. Looks like it did. Yeah, I've got my housing fact table. I should see one-to-many relationships almost across the board. So you can see I've got a one-to-many relationship between my housing dimension and my housing fact table, the same for features, the same for schools. However, just like I told you when I created my location data, I didn't reduce this table at all, which is why I have a one-to-one relationship between my housing fact table and my location data set. If I go to my housing fact table, you can see I've got 15,171 rows, and I should have the exact same number of rows in my location data set because of how granular all this information is, and that's fine. What I want to do now is I want to resave this report and call it something different. So let's go ahead and call this housing data tutorial. Let's go ahead and save it. And I want to go back to the folder where I saved those 2 files. And I want to point out something, and that is that I have my test file was 5,318 kilobytes and my housing data tutorial is 5,015 kilobytes. So notice that I have a smaller file here after cleaning up my test data. So even though I created more tables and did quite a bit of cleanup on the underlying data. I just wanted to point out that my data, the size of my data set is actually getting smaller the more I clean it and the more I model it. The last table that we're going to create as part of our modeling should further reduce the size of this data model. How much is honestly kind of a guess at this point, because this is going to be some pretty intense transformation that we're about to do. And honestly, I don't even plan to finish the transformations that I'm going to show you. I'm going to sort of give you the tools and let you determine how much you want to continue cleaning this thing up. But what I want to do is I want to go over to our housing fact table, and I want to focus on this gigantic text field that we have in here that honestly is probably making up most of the size of this data set and the Power BI report as a whole. This is a lot of data here, a lot of free text. And we want to try to figure out how to do something with all of this text information. I mean, in this age of GPT and AI and machine learning, we could probably find something to run this field through, something that's really made for it. But I'm going to show you how to do something out of the box just by modeling this data that can at least help us start making some very rudimentary, Power BI visuals and charts sort of explaining what people are talking about without having to use any kind of serious data science model or without having to partner with someone else or use another technology. We're just gonna rock and roll on this thing using the Power Query Editor. And it's also going to be a good exercise just for sort of teaching you some Power Query Editor techniques that you can use across future projects. I use this technique all the time. Is it perfect? Absolutely not. Is it a little bit tedious? Absolutely yes. But it's not that bad. And I'll show you what we can do pretty quickly. So let's go ahead and head back to the Power Query Editor. Don't know why it popped up on my other screen. Let's drag it back over here. And let's go ahead and reference our clean data set again. The only things that we're going to need for this exercise are just our ZP ID column so that we can map all of the transformations that we're going to do on this description field back to our housing fact table. We're going to remove everything else. And I'm going to take my description column here. And what I'm going to do is I'm going to split by a delimiter, and the delimiter that I'm going to split by is a space, because you can see I've got a whole bunch of different words down here with spaces in between them. So I'm just going to hit OK, and now you can see what I'm left with here. Absolutely gorgeous 4-bedroom home. Like, in other words, if you read across, you'll be able to actually read the sentences. But notice I have 528 columns now. Basically, that means that the longest description in my data set had 528 words separated by spaces. You might be thinking, Sean, what the hell am I supposed to do with 528 columns? Well, we're not going to use 528 columns. We're only going to use one. What I'm going to do is I'm going to go all the way back over here to the beginning of my table. I'm going to select description 1. Then I'm going to hold down Shift and select description 528. And if you're ready for this, let's head up here to transform, and I'm going to unpivot all of those columns, basically reducing them down to a single value. And so what this gives us is an attribute column that just references the original column that this word belonged to. We don't need this. I'm just going to remove the attribute column. And now what we have here is, let's go ahead and scroll down to the next one. Yes, let's focus on this property 1209000430. All of these words, if we just read them together, are going to map the description that was originally in this field. So absolutely gorgeous 4-bedroom home with 2 full baths located in the tucked away Pflugerville community, the lakes at Northtown. This home was recently updated with new carpets, new tile kitchen, backsplash. This is all just a sentence, but we've broken this sentence down into the unique words that go with it. Now what we want to do is, you can see that there's a lot of garbage in here too. Things like commas and periods and what we call stop words like and, the, in, it, a, things that don't really tell us all that much. This is where this part of the modeling exercise could take hours, if you wanted it to. We could sit here and take this gigantic table and just continue, getting rid of things that we don't need. Like we may not need the word Victor. That probably doesn't tell us much. It's, obviously a part of a name. We may not need things like SQ and feet that are shorthand for square and feet. It's up to you as to what you think could just be noise in the data. What we are going to do real quickly is let's just go ahead and grab as many different punctuations as we can and just get rid of them. So let's go ahead and go up here to replace values. First, I'm going to grab all commas and I'm going to replace them with nothing. So this goes pretty quickly. If you want to keep your eyes up here on this doctor comma, let's go ahead and just hit OK. Notice that the commas disappeared. In fact, all commas in the entire column just disappeared when I did that. And now let's replace all periods with nothing. And you can see I've got 2012 period. If you keep your eyes focused on that as I hit OK, notice the period vanishes. All periods are now gone. What I like to do is I like to just take the punctuation notes on my numerical keys and just get rid of all of those. So I'm going to get rid of my exclamation marks. Let's go ahead and get rid of any ampersands in there. Let's go ahead and get rid of any hashtags. Let's go ahead and get rid of any dollar signs. Let's get rid of any percentages that should be in there. I doubt that any carets are in there, but let's go ahead and get rid of it just to be thorough. There we go. Let's go ahead and get rid of any asterisks. And one thing that you don't want to forget is to get your parentheses and closing parentheses. And you might even want to get rid of brackets. Brackets pop up quite a bit in these types of data sets. I also like to get rid of hyphens. The whole goal of that exercise was to reduce as many punctuations as we can. Notice that before I removed any of those punctuations, we had dollar signs up here, periods, hyphens, asterisks, quite a bit of noise. And by the time I get down here, a lot of those weird values are gone. I do see some semicolons and some backslashes and some colons. No problem. Let's just go ahead and get rid of those real quickly. So backslashes are gone. Commas or colons are gone. And what was the other thing? Semicolons. There we go. They're gone. Now let's just go ahead and remove anything that's blank. Let's go ahead and get rid of, I'll come back on the text here in just a minute, but let's go ahead and get rid of any blank values. Now, the next thing that I want to do is let's go ahead and try to figure out a way to remove anything in this data set that is just a numeric value, like 2010, 2012, 2013. Those just don't really tell us all that much. So I have a bit of code here for this that should help us do this. Let's go ahead and go to add column. We're going to add a custom column here. And what we're doing is we're basically asking Power Query to tell us if the value, and we're going to derive a value from a text field. And in this case, it's confusing that our column is actually called value too. So this is what this is referencing. We're taking our column, we're converting it to just a raw value, and we're asking Power BI to tell us whether or not that value is just a number. And so you can see here, I've got true for 14,424 or 14,424, probably a zip code or something. I've got true for 78,660. I've got true for 2601. So this appears to be working correctly. And what I'm going to do is I am just going to grab all of the false values to just leave me with text. And once I have that, I can just remove this column. I'm not going to need it anymore. I just wanted to get all of those numbers out of the way. The next thing that I'm going to do is I'm going to extract the length of each word. So you can see Lake, 4 characters, Victor, 6 characters, DR, 2 characters. What I'm going to do here is I'm going to remove any values in my value column that are less than 3 characters. What this is going to do is it's going to get rid of things like A, N, or, and some abbreviations that just don't really tell me all that much. So let's just go ahead and get rid of them. Once I have that done, I can go ahead and get rid of my length column. The next thing that I'm going to do is let's go ahead and transform our values, and we're going to capitalize each word. And this is where things can start to get pretty tedious, and you're going to start to notice some oddities in the data, like this 1550 mo, 1750 mo. I'm not sure exactly what is causing some of this dirty data, but chances are any of these values are going to be pretty rare. Let's go ahead and just show you what I mean. I'm going to click on 4 of these. Hopefully, after we filter, we only see those a handful of times. You can see that this is a pretty large sample of our data that it's combing through. So the load is down here in the right corner, and you can see that Power BI is taking a minute here. Okay, so yeah, there's a fair number of these 1800 modes. I've got 192 values here. So we're just going to leave those in. That's what I meant when I said you could go on filtering and cleaning this thing up all day if you want to. I'm not going to clean these values up, but I just kind of wanted to let you know that when we're doing it this way, you're going to end up with some odd things like 2 bath, 4 bedroom. It's not a big deal. What we're interested in doing now is just going through and cleaning up some common words that probably don't tell us this much. And I don't want you to belabor this, but let's go ahead and just remove words like all, and. I'm really looking for a lot of 3-letter words. The reason that we're removing these is that if we don't, they're probably going to come up, they're probably going to bubble to the top, right? How many times do you think has and have and things like that are being used? I'll just remove this since I'm here. Let's see. Into is probably a word that is going to appear a whole bunch of times that doesn't really tell us anything. Let's go ahead and get rid of not, must, only, let's see, other, I'm making my way down to TH, where I'm going to come up with a whole bunch of things: than, that, the, there, this, through, throughout, upon, under. Always a whole bunch of prepositions and conjunctions and things like that. You, your, yourself. Won't, with, within, would. Okay, we're just going to go ahead and cut it off there. I could spend all day going through and getting rid of words that appear a whole lot in language, but are probably not all that relevant. Once we're done with this, let's go ahead and just change the name of this table to description. Let's go ahead and close out here. This is going to take a second to load because this is now going to be the largest table in our data set by rows. Once this is done, yeah, you can see it was about 754,000 rows. There's our descriptions. There are all of the homes that have the word home that appear in them, which you can imagine in a data set like this is probably a lot. Let's go back to our housing fact table. We no longer need our full written description. Let's go ahead and close out of this. Let our fact table reload. Let's head back over here and make sure that our description table got hooked up correctly. Looks like it did. I'm going to kind of pull this over to the side here. There's our descriptions. It's now a many to one join based on ZPID. And you can see the size of that description table is 754,301 rows. But let's go ahead and resave our housing data tutorial. And I want you to notice here, when we go back to our tutorial, look at how much smaller our housing data tutorial file is now. You'll remember that it dropped a little bit from like 5,318 kilobytes to just, almost 5,000 even. Now it has dropped all the way to 3,000 kilobytes just by removing that description column from our housing fact table. So even though we now have a 54,000 row data table, it only contains two values, and one is our numeric key and the other are all of these unique words. But that's still a much more efficient way of storing that text information than in that long string value that repeated 15,000 times in our original data set. So by removing that and remodeling these words the way that we have cut the size of this data set by 35-40%. And we can now use that text information to actually, glean a little bit more useful insights really quickly from our data. Let's go ahead and grab our value from our description here. And let's grab count from our x-axis. And you can see, okay, home is the top word that pops up. That makes sense. Followed by kitchen, followed by room, followed by large, new, bedrooms. So these are telling us all the things that are most important to anybody who is, potentially looking at a house. Obviously, they're looking for homes. It's debatable whether or not this word even tells us anything. We could remove this, but knowing that the word kitchen appears over and over again, that's useful information for somebody who's looking to analyze this data. People are looking for rooms. People are looking for, large houses, large rooms. They're looking for multiple bedrooms. The Z estimate is probably important. They're looking for places to live with their family. They're looking for possibly open concepts, when it was built, things like that. So let's go ahead and head back up here to our description data set. And real quickly, while I'm thinking about it, let's just go ahead and also scroll down and remove the word for, since that was appearing. Let's go ahead and reload our description data set, and let's see how much removing that may have further reduced the data set size. We'll go ahead and reload our description table. It's about 10 megabytes, I think, so should wrap up here in just a moment. There we go, 11 megabytes. And you can see that just removing the word for from our description table dropped this housing data tutorial size under 3,000 kilobytes. So we're now at about 2,973, very, very close to 3,000 kilobytes. But now you understand the importance of modeling. Yes, this is a fairly small data set. 5 megabytes for our original Power BI data file when we were using the unclean data set is not a big Power BI file. You're probably not going to run into many performance issues. You're probably not even going to run into that many problems with relatively inefficient DAX. But at scale, when you have millions of records, being able to properly model your tables and create a proper schema is going to have huge implications for the size of your file and the performance of your overall report. I barely did anything at all. Everything that I just showed you took me less than an hour and would have been even faster if I wasn't talking and narrating the entire time what I was doing. And I was still able to reduce the size of my Power BI report by, 40%. Those are incredible gains on such a small data set. That's why this is so important. So I just wanted you to understand not just how to model, like we've been doing, several times in my videos, but why we do it and why it's going to be important as you start working on larger and more complex business intelligence tools. But let's go ahead and now change our attention or pivot from working on our data model to actually starting to build out some data visuals and some interesting insights from this data set.